This
And
conference will now be recorded.
good afternoon, everybody. My name is Fernando Valera, and welcome to the How to Get Started with the Formalized Requirements Process in Embedded Development. You will be muted throughout the presentation, but we will have some time for a Q&A. So feel free to post your questions in the chat window, and Joachim will be reading them out loud unless there's, any question that needs to be addressed online. Also, we'll be sharing the recording of the session, so you will be receiving a follow-up email with the download link, or at least the link to be able to re-watch this session. As Joaquin mentioned, my name is Fernando Valera. I'm CTO at Visual Solutions. I'm located in San Francisco, California, so pretty early for me today, but really glad to be here and to have been invited by Know How to do this presentation. Just a little bit of background of the organization. Visual is a leading provider of requirements ALM tools, hence the title of defining an embedded process. Even though we are focused on requirements engineering, we cover other aspects as well in the ALM. Today we will be presenting the different steps for deploying such a process. So as you already know, the key and the secret sauce, even though it's not very secret, of deploying a process is basing it in three main steps, which are basically training of the different employees or members of the team that will be participating in the process, defining the correct process, and using tools. So all these legs have to be there. You cannot have an efficient process without a tool, without training, or without a well-defined process. But also there are other things that need to be taken into consideration, right? So for instance, one of them is reusing existing information, reusing documents, right? So that's where we will have to make use of the tools such as Visure. So the majority of the organizations already have documents in Word, in Excel, but also we might have other organizations that we work with that we need to exchange information. So this can be done also by means of RecIF. So RecIF is a standard primarily specified for requirements, so we can exchange different specifications, traceability, attributes, and so on. Once we define all the process and import all information, we will actually hit some challenges and some aspects that parts of the process or the standards might not be very helpful because they are very specific to our organization. Some of them are related to the variants and product lines. So how are we going to treat our developments? What is our system? Is our product the system, or is our product a part of a bigger system, like a fleet of cars, or are we having telemetry to our system, and therefore we have a broader data analysis system? How do we want to work with those, right? The configuration management, when we get to this point, is usually a challenge in the sense that we are, as an organization, through uncharted territories that we have to be able to deal with them. We will talk a little bit about that during the session, but also we have to understand that variants are not the same as reusing requirements, which is definitely another topic in itself, being able to reuse the same requirements that we had in the past, be able to branch them, be able to merge them, and so on, right? Apart from that, we need to make sure that whenever we have a very complex process or a very simple process, requirements go through the corresponding review process. Another topic that is absolutely key in all this is that even though we might have a phenomenal process, we have to make sure that requirements quality is there. It doesn't matter if we are treating requirements or following an ISO standard or whatever. If requirements are not well written, everything will fall apart eventually because we are introducing so many errors. So the tools can help in here just by analyzing the quality of the requirements, apart from defining different review steps, checks, and testing methods and activities. And traceability is what will glue everything together. So needless to say, Vischer covered each one of these topics individually. We will not be able to cover all of them today. We have only 45 minutes. It would take us hours to cover everything, but I will do my best in explaining some of them in detail. And finally, everything that we do has to be with a specific goal in mind, which is achieve the certification. Whether you are in automotive, aerospace, railway, medical devices, etc., we need to make sure that we establish the correct traceability, that we maintain that traceability, and that we establish it from the beginning to the end, even up to the source code. And that applies for the software, the hardware, and usually we want to get all other parts included, like mechanical and so on and so on, right? So we will talk a little bit about how Vischer helps in this aspect as well. But let's start with the importance of requirements. And I would like to start with some definitions. I would like to start with definition of the function. Function is the behavior intended for a thing. So when you get into a systems engineering course or even a requirements engineering course, you will hear a lot the term intended function, right? So most of you will already be familiar with this term. So it's what we want the system to do. The system design is actually the process of defining elements of a system like modules, architecture, components, and the interfaces and data for a system based on the specified requirements, right? So we cannot have a system design without the requirements, right? So we are defining the intended function, and then we're defining the system design based on those functions. So when it gets to the different standards, we will have to implement safety measures, right? And software safety and system safety and so on. So it turns out that the safety assessment process is a methodology to evaluate, in this case, aircraft or system functions and the design of the system performing these functions to determine that those associated hazards have been properly addressed. Essentially, what this means in a nutshell is that it's impossible to have functional safety without good requirements. So if you have to comply with any standard, requirements is the place to start with. Even though, well, that's kind of an obvious thing. I like to illustrate this with, the quintessential diagram about this wing. Probably you've all seen this already, but as a refresher, we get a request from the customer, and usually we see the point, but it doesn't kind of make sense already. It's kind of weird. We would certainly do it in a different way. But then the project manager kind of tries to, fix it and amend it, and then, some of the requirements don't make it through, and then the system doesn't make sense at all. But and that's the point where we call a consultant, and everything is, perfect and fantastic, but way over the top of what is needed, right? So we go back to the original request and we try to make it work because that's what we do, and we are engineers, right? So we just try to implement some fixes here and there, and we will make it work no matter what. But then all of those decisions that led us to the final system are not even logged anywhere. So when someone looks at the system, it's like, what the hell? How this? How could this happen? It's like, well, there were reasons out there. Um, Especially when you look at the cost, because it looks like you built a roller coaster. Well, the most important thing is that what was really needed, the intended function, was not related to what the customer said that they needed, what we understood, what was implemented. What is truly needed is exactly that, what is needed. So it is our responsibility to investigate to get to that point. So how do we implement this process? So the first thing is by implementing an iterative and incremental process. And it doesn't usually matter whether you're following one methodology or other methodology. It's just the methods and the tools that will be different. But essentially, you will have to start with, different steps. And in particular, if you're following one of the standards, they require you to start with the definition of the higher level intended function, right? What is the system going to do? Is it going to fly? Is it going to drive? Is it going to, keep the heart beating? And each one of those intended functions is meant to be a commitment to a lower level. In this lower level, we will make some decisions on the architecture of that level. So if we want to make the system fly, okay, we have to implement different engines and wings and this and that. And that level will become at the same time a commitment to yet a lower level until we get to the software or hardware components, which will be the actual implementation of the system. So each one of these levels will have its own process on its own until we actually refine those requirements and we feel comfortable with them to go to the next level. But the other very interesting thing is that each one of these levels act also as a high level goal from a perspective that when we are building the architecture, we need to be critical with the higher level requirements. And even though all of you are most likely familiar with these steps, what I found in many organizations is that the most fundamental problems that they're having can be solved by just going back to the basics of this slide. So for instance, if you're having an issue at the software or hardware level where you cannot implement a higher level requirement because it's impossible, it's not technically feasible, well, it turns out that you have to be critical with those requirements and you have to negotiate those requirements. So you might not be able to achieve that requirement, and therefore that subsystem requirement might not be possible. Therefore, you either change the architecture at that level or change the system requirements. And that's due to the fact that when we're writing requirements, we're building a system that does not exist. So in some cases, we don't even know whether the technology is there to support that. Right? We're building something with new technology. So we have to explore different architecture and different possibilities. So usually, the way of implementing this process is a V-life cycle, even though when we get to the lower levels, we might actually implement an agile process, right? So the authorities will require you to kind of demonstrate that you're following a V-life cycle nonetheless. So the traceability will have to be there down to the source code, even though at some point you can spin off some of those requirements and convert them into user stories. But the most important thing will be to have the different test cases of full coverage of the requirements and full coverage of each one of those levels. So again, you will probably be very familiar with this V-life cycle, but then everything gets interested when we actually get to the point of decomposing the system into different subsystems, right? So as we mentioned earlier, we might have this aircraft, for instance, that divides into engines and wings and batteries and thrust systems and gas and so on and so on. And each one of them at the same time, they develop into subsystems, right? So one of the things that we will eventually have to do is map that V-life cycle to our architecture, right? So one of the keys in this at this point in time is to be able to actually represent that architecture and then start working based on the concept of systems of interest. What does that mean? Well, what it means is that even though we have all this kind of system decomposition and we implement a V-life cycle and or agile hybrid processes to support the certification, but also an efficient process, we have to make sure that whatever team is working on the system gets laser focused on their system of interest. So let's imagine that we're working on the airbag. So the airbag will have a representation like this. And this is actually a screenshot from Visher that we will see in a couple of minutes. And we see how we have the different folders and subfolders to represent the specifications for the actual system, the airbag, as well as the subsystems like the sensors and the inflator system requirements and so on and so on. Good. So once we have the representation of all the specifications of the system allocation, another thing that we have to represent that we enable in Visher is the traceability between all those specifications. So in Visher, we have what we call the data models. So data models put the that folder structure in context and allows us to actually represent those boxes in the system allocation in a diagram and say, okay, this element traces to this one and this one traces to this one. Like if this is like in here, this is a screenshot from Visher where we have a system requirement tracing to the airbag requirement specification that we had in the previous folder structure, which at the same time decomposes into impact sensor requirement, inflator requirements, etc., etc. And this diagram is just one of the multiple diagrams that we will have in the system. The key thing here is that a team will be able to select one of these diagrams, and that will be their system of interest in the sense that they don't care about anything else, right? Good. Let's move on, and we will get into the demonstration in a couple of seconds. Just to mention that in this case, we were taking a look at autonomous car or whatever. But in Visure, we actually have templates for these data models for different environments, including a general 61508, but in particular aerospace, automotive, railroad, medical devices, IT, also pharma, uh, GAMP5, and so on. Good. Let's move on to the demo right now. And what we're going to do is that we're going to start by demonstrating how to actually import a document in Visure. So this is Word, and probably you have Word specifications like this, where you have a table of contents and some requirements in chapters, or you might have a completely different Word document, or even you might have an Excel document. It doesn't matter. In Visure, we have these plugins embedded in Word and Excel that will enable us to capture all this information, right? And what we do is that we have multiple methods. We can use it based on tables, styles, text, that sort of thing. And the plugin will actually detect each one of the paragraphs that we want to import, either as a chapter or as a requirement. And we can actually navigate through the elements that we have detected here to make sure that everything is being detected correctly. And then the only thing that we need to do is actually select the project, decide the specification we want to include it in, and up here we can see that the status is new, right? So one of the things that this plugin does, which is extremely useful, is that it detects whether the information that we're importing already exists in the database or not. In this case, the specification is new, so that's what it's indicated in here. But if they already existed, it would indicate that the elements are modified, for instance. This allows us to keep receiving information from the customer and detecting any specific change or whether the requirements are identical. You can also export from Visure into Word and Excel and re-import that information back as well, right? Okay, so you can see that it completed importing the entire document pretty fast. And what we're going to do is that we're going to open Visure at this point. So Visure is provided in two different environments. We have a desktop application with the entire functionality, all A&M, and then we have a web client. It does have reduced functionality, but it allows you to pretty much manage all the requirements, manage all the let's say test cases, change requests, etc., right? And what the first thing that we're going to do is take a look at what we call the folder structure or the specification view. In the specification view, we see all the different specifications as documents within a folder structure. Pretty much what you are currently used to with a Windows Explorer. One of these specifications is the PRD for the Visure import, and this is the document that we just imported. So actually, let's double click on this document and let's take a look at what was finally imported. So what you can see here is that we have pretty much everything that we had in the actual document, including the pictures, the tables, everything. What I'm going to do here is that I'm going to include another attribute here. And this one indicates whether the element is an actual chapter or whether the element is an actual requirement. And you can also see that the import was smart enough to differentiate between those chapters and the requirements. Good. So what are we going to do right now? Well, usually the first thing that I would do is to filter to see the actual requirements. So what I'm going to do is I'm going to apply a requirements filter to just remove all the chapters from there. And then I'm going to select all the requirements. I'm going to go to the plugins, and I'm going to analyze all these requirements. So that's kind of one of my basic actions whenever I import something from Word. And what this does is that it calculates the quality of the requirements automatically. So you will have noticed that there was this column, the QBScribe requirements score, which is basically empty, and now it indicates with kind of a orange or a green indicator the quality of the requirement. So we can see that many of them are pretty well written, pretty acceptable. And here we have a 5-star ranking, which is pretty good. The rest are relatively good. This one is pretty low because actually there's no requirement in there. But what's the problem with this one? What we can do is that we can go to the Properties tab, and we can actually go to the Quality tab to actually find out what the issue is. And this will highlight the fact that we have a word that says all modules. So all is something that we typically use in most specifications, but nonetheless, it's pretty risky to use all because we are being implicit about the modules that we are affecting. So we should actually be referring to the specific modules, right? So the quality analyzer will highlight some aspects, and then it'll be up to you to decide what to do with them. Good. So let's actually go back to another specification, like the product requirement specification, where we already have requirements that we have been analyzing, we have been working with. And the reason I'm changing to this other specification is because this one already has traceability in there. So one of the things that I would like to do is, first of all, check this element out. And let's say that we want to approve a requirement, right? So the first thing that we're going to see in Vischer is that we have the capability of defining approval and review workflows. And even though in each organization, it will look something different, but in most of them, it'll be similar to this, going from new to review to finally approved, rejected, or something like that. Small variations of this, hopefully. So this attribute follows that defined workflow. So I would be able to now transition it from new to review, right? And also from review to, let's say, approved. Okay, so let's check this requirement in, and I was able to perform all the transitions because I have assigned all the roles to myself for the sake of the presentation. This would be a more mindful and thoughtful process in each organization, but we just have to follow an entire process in 10 minutes. So let's pretend that we have completed that approval and review workflow. We also have the possibility of creating baseline. So once all the requirements have been approved, we can baseline the entire document, or we can baseline the entire project as well when we reach a milestone. But also, we can make use of the comments. And let's pretend that this requirement actually, let's say that it's actually not a hospital. It can be anything else, such a, let's say, a camp. Please correct. Good. So we will see that this requirement now has an unresolved comment here. So what do we do at this point? Do we change this requirement? It is already approved. So some organizations will block a requirement when it's approved. Another possibility will be that the corresponding users will be able to check out this particular requirement, and let's actually make the corresponding changes here. Facility. So changes can have a more, as I mentioned earlier, thoughtful process by basically creating a change request, following the change request, and so on. That is also possible in Visure. For the sake of the demo, considering that we have approximately 10 minutes left, just want to show this part. However, when we get to finally implementing the change, two things will happen. The first one, we cannot make a change and the status stay as approved. So Visure can implement what we call the triggers that will revert the workflow back to new state. But also, we have to notify other users from lower levels that we made that change. So whenever I just go and get out of this requirement, we can see that the status changed automatically and a set of notifications were triggered in here. So let's actually jump to any of those. So right click, and we can see actually that the system requirement specification, the system engineer will have a heart attack here next time he or she opens the specification, because based on multiple changes, everything is in red and in suspect, right? So we will have to actually review the impact and eventually adequate this requirement or not, or simply remove the suspicion, just simply by right-clicking and deleting the suspicion. Probably before that, what the user will want to do is go to the properties panel and actually check the different versions. And the different versions will tell us who, what, and when changed. And here we can see that the status went from approved to new. We already know that. And the description changed. And if we click in here, this will tell us exactly what changed. So hospital was deleted, facility was deleted, and so on. Good. So here we see the actual traceability. So we saw that this element has several arrows, and hopefully you assume that that means incoming and outgoing traceability. Actually, this element has a related change request and has some system requirements related to it. So how do we establish traceability, and how do we manage that traceability? Well, the first thing is that in the properties panel, here we have the linked items tab. In here, we can actually establish that traceability. The first thing is that we select the specification we want to trace to, and then we establish the actual traceability. However, it's interesting that in here, we only see a subset of the specifications, for instance, the system requirements. But where is my PRD, the product requirements document that we imported earlier? It's not in the list, right? So, well, I will cover that in a second. And just as a disclaimer, that's because the data model is enforced, and we not only represent in the diagram the that V life cycle or the systems of interest, but we actually enforce that traceability so users cannot do anything else than what is defined in it. But before that, one of the things that I wanted to show is the fact that once we have all this traceability established, we can actually start working with it. Before even changing this requirement, one of the things that we would have liked to do is go to the views and enable something like this view, the impact analysis from product requirements, where we have the same product requirements, but now we have them in kind of a hierarchy view where we see all the decomposition to lower levels. So for instance, we can see how this product requirement actually traces the system requirements, and each one of the system requirements traces downstream to mechanical software requirements. And we already see in here the actual traceability to test cases, and we can see the result, the pass, pending, fail. If those test cases, we can actually see them here as well. We can see the actual executions of those. And eventually, if we expand the tree, we can also see it. I'll make this smaller so you can see. We can see that this test case that was failed comes from this execution that was failed that results into a defect in Visure. This defect can also be synchronized with Jira, for instance, for the follow-up of that. So this kind of trace matrix from requirements to the lowest levels can also be exported to Excel simply by clicking that button, and whatever columns we would like to have will actually be exported to Excel. And here we have product, system, mechanical requirements, the test cases, test executions, defects if there are any, and also we will see the actual result of the test cases in here, and so on and so on. So full end-to-end kind of trace matrix in there. So I was mentioning about the data models. So if we click in here, we actually go to the complete list of data models in this project. And in here, we can see that we have multiple of them, system process, one that talks about the test management, risk management, one describing the agile process for the software parts of the system, issue and defect tracking, and so on. Let's actually open this diagram. So what we can see in here is an actual V life cycle where we have product, system, and component requirements being mechanical, electrical, and software, and the different test cases at each one of those levels. We have an additional component here, global parameters. It's something that we haven't spoken about, but essentially we can create sort of a dictionary of parameters and have references to those in the requirement descriptions. So we don't have to repeat those elements over and over again, like the maximum speed of the system, right? And they can be referenced by either requirements or test cases and so on and so on. But the interesting thing is that we do not see the PRD in here. So that's the reason why we were not able to establish that traceability. So what I'm going to do is that I'm going to bring the PRD here. So what I'm actually doing is that I'm including the specification that we already have in the folder structure in our diagram. And now what I'm saying is that this new specification should actually be traced to this and that type of specifications in our system. So now we have included the specification within the context of our process. So it's already 3:40. I wanted to leave 5 minutes for Q&A. Joaquin, I don't know if you have some questions for me from the chat panel. I would also like to remind one of you to post your questions, whatever questions you might have in the chat panel, so that we can address them. Mm-hmm.
Yes, I got some questions. So can you hear me, Fernando?
Yes. Yeah.
Okay.
I can hear you.
Okay. So the first question is, there are several requirement management solution on the market, like IBM, Rational Doors, PTC, Integrity, and so on. So what is the advantage of Visual Solution or Visual Requirements?
Yes.
It's a difficult question.
It's a difficult question, like asking, like, what's the meaning of life, when there's a minute left. But I'll try to answer that. Essentially, Visual has been growing the past years significantly, and that's due to our focus on the different regulated sectors, as I mentioned earlier, aerospace, automotive, basically regulated environments, right? So we bring a lot of expertise into the tool. We are very reactive because we are not a gigantic company that only reports to Wall Street. We only report to our customers. That's the key thing. So in the past years, we have had a phenomenal progress in the tool. For instance, global parameters is just one of the multiple features that were requested by our customers, and it's very unique to Visual. The data models are very unique, and basically the responsiveness as an organization is key. So I would, in 15 seconds, basically, our functionalities are unique. As an organization, we're very responsive to our customers and attentive, and we are very specialized in regulated environments.
Yeah. Another question. If I have, for instance, doors, is there any integration possibilities to Visual?
Yes. And it ties into the previous question very nicely, because we actually have a lot of customers currently migrating from doors for obvious reasons, right? So we typically use RecIF to move all the existing information from doors into Visual. We have been doing it, for quite some time, and it works pretty well. But it not only allows you to actually escape from doors, but also it allows you to maintain an integration with doors. For instance, if some of your customers or suppliers are still using doors, or some departments have not migrated yet. So RecIF would be the actual key for that.
Okay. I have another question here. Does the Visual come as a box version or a cloud solution?
Both. We do provide an on-premise solution, and we provide a cloud solution. It depends on your sector and environment, whatever you would like to go for. Our on-premise solution, you just take care of absolutely everything. In that method, we have both permanent and subscription licenses. For the cloud, well, it's obvious subscription licenses, but also it's a single tenant solution. And this is absolutely key, because the system is still qualifiable. That means that if you're in a regulated environment and you have to certify the system, you can actually get it certified, and it will not be upgraded automatically without your consent. And you will remain in a specific version unless specified otherwise, right? If you would like to stay with the latest version, that's fine. But if you certify a version, you can stay with that. Mm-hmm.
Yeah, it was also a question related to that. Is the system pre-validated for use in the medical device industry? And will it be possible to provide with the relevant information or documentation?
So the answer is yes. For the medical device environment, it has been pre-qualified. That means that you have to go through to the certification of the system again in your own environment. So 62304 requires to qualify the system in your own premises once it's installed, with your process, with your hardware, etc., etc. So what we do provide is a qualification package that you can use and then just follow the qualification package to qualify it.
Okay, then there were a question about subscription and one-time purchases, but I think you already mentioned that they are both available.
Mm-hmm. Yep. Another question that you might have is related to the types of licenses. So we provide floating licenses. This is also quite an advantage opposed to named licenses exclusively, because floating licenses or concurrent licenses allow X number of users to be working at the same time, but those users can be different each time. So if you have, let's say, a team of 10, 15 users, you don't necessarily need to buy 10 or 15 named licenses, right? Which is for most of the tools pretty expensive. Rather, you can actually get approximately 5 licenses for the 15 users, or something like that. Max 3 licenses for the 10 users. And those 10 users will actually use it, but not all the time, right? So whenever one user stops using it, another one can start using it, and so on. The traditional named license.
One other question, is there any integration with bill of material or ERP system, enterprise system?
So it depends on which ones in particular. So we have our integrations are one-to-one, and we keep increasing the list. So we would need to know which one in particular you're looking into. So if you can chat it with every, then I can give you an answer.
Yeah.
Traditionally, we integrate with, let's say, document management systems, design systems, modeling, issue tracking, test management systems. That's usually the integrations that we provide.
Yeah, I got a chat in the chat window that it's not decided yet which system they're going to have.
So for instance, we are pretty flexible in terms of integrations. What we provide our customers is that if the system is mainstream or, it's not homegrown, it's an existing interesting system for us, we build the integration for free, provided that it will be used by other customers in the future. So the only cost is the cost of the actual license of the integration, right? But there's no extra cost associated to that.
Okay. So I think I have no more questions right now, so I think we also just a little bit over time. So I would like to thank you very much, Fernando, for showing this. And if you have more information, you can always contact me or my other colleagues at Know-How Solution.
Well, thank you so much, Joachim, for everything, and thank you everybody for attending today. I hope it was useful and that you know there was something that you learned today. You can contact Joachim, and as he was saying, with any questions or comments or feedback, we would really appreciate that. And I hope you have a good rest of the day. And back to you, Joachim.
Yep. Okay. Thank you.
Thank you. Bye.
Bye-bye.